In this video, we're going to look at the connection between the angle of inclination of a straight line and the slope or the gradient. It's actually a lot more straightforward than you might imagine. In fact, I think sometimes it's so straightforward that students get themselves all tied up in knots thinking that it can't possibly be that easy. Well, the good news is it is that easy. So I'll just do a couple of quick examples and we'll see how simple that connection actually is. Okay, so the angle of inclination is the angle that a line makes with the positive direction of the x-axis. Now, when we talk about positive direction of the x-axis, obviously positive is this way. So we're talking about this side of the x-axis. So the angle of inclination is that angle in there between the x-axis and that line. Okay, so clearly if the line is positive, has a positive gradient, it's going to be somewhere between 0 and 90. Okay, and if the line has a negative gradient, then it's going to be obtuse between 90 and 180. So that's theta there as well. Okay, so when we're talking about angle of inclination, that's all we're looking at. So always measured sort of on the right side of the line, if you think about it that way. So the relationship is, like I said, it's fairly straightforward to work out. And so if we look here, we've got an angle of 30 degrees. So if we draw a triangle like that, okay, and we'll say we draw a nice right angle triangle, so that's 30 degrees. Okay, now we know that tan of 30 is going to be opposite over the adjacent side. So that's opposite, that's adjacent, opposite over adjacent. Okay, but we're trying to relate this to the gradient. Now we also know that gradient is rise over run. Rise over run. Okay, and for simplicity's sake, we're just going to set the run at 1, and then we'll look at the rise, which maybe we'll just call r, or h even, for height, for rise. Okay, so we're going to say that's h over 1. Okay, so we just arbitrarily set 1. So for every unit you go across 1, you go up h, which means that m is equal to h. Okay, so the gradient is that value there. Okay, tan of 30 is also going to be h over 1 because it's opposite over adjacent. Okay, h over 1 or h, and we've just shown down here that m equals h, therefore tan of 30 must equal the slope. So what our relationship is that tan of the angle of inclination is equal to the gradient, and that's all there is to it. So let's have a look at a couple of examples. So we want to find the angle of inclination of the line that goes through these points. So first thing you want to do naturally is draw a sketch. Okay, so we have draw ourselves a little set of axes. Okay, we've got -3, 2, so that's somewhere sort of over here. It's -3, 2, whoops, not -2, -3, 2. And this is 5, -4, somewhere down here. 5, -4. Okay, we want to know the angle of inclination. So we now know that tan theta equals n, and we're trying to find theta. Okay, so if we drew a line between there, so we want to find theta, which is this angle here. Okay, what we should be able to see is we can find this angle fairly easily. This is, so I'll do a different color so you can see what's going on. So this angle is the same as this angle due to similar triangles. Okay, let's just call that phi, so we don't get ourselves mixed up with theta and phi. Okay, and if we look at our right angle triangle, that's our tan of that angle is going to be opposite over adjacent. Okay, and we know that our height here, our opposite, is, if this is -4 and this is 2, that distance there is going to be 6. Okay, and if this is 3 from here to the axis and from there is 5, that's going to be 8. Okay, so tan of phi equals 6 over 8, which gives me a value of phi of 36.9. And then obviously from there, theta is going to be 180 minus phi equals theta. So theta will be 143.1. All right, but that in doing that, we've sort of done that a bit more with trigonometry or geometry rather than actually using our equation up here. So what we can do is say, well, let's look at just the gradient. So if the gradient's rise over run, it's negative because it's sloping down. So let's do this the other way. So m is negative 6 over 8. Okay, rise over run. And then we know tan theta equals that. So tan theta equals negative 6 over 8. So theta will be, and if we go over here, oops. So we want trig, we want inverse tan of negative 6 over 8. It'll be interesting to see, make sure if we're in degrees, what, so that's going to give us a negative. Okay, fair enough. You can also put, given that it's between, that it's a positive value, okay, but you should be able to work out if it's giving us a negative value, then the equivalent will be this angle over here, this obtuse angle. Okay, using our cast on our unit circle and the properties of positive and negative values of sine. Of tan. So that's negative. So that's giving us negative 36.9, or for the obtuse equivalent is our 143. Whoops. 0.1. And if you just want to convince yourself of that, not that one. You can go 10. Where are we? Oops. Now we're up here. So we can check this. Tan of 143.1, 143.1 equals, and it's close to negative 0.75. Okay, so it's not exact because we've rounded this number here, but it's close to negative 0.75, which of course was our gradient here, negative 0.75. Okay, so just showing the relationship between tan of that angle of inclination theta and the gradient of that straight line. Okay, second example, we've got slope of a line, so find the slope, so we're looking for the gradient, that makes an angle of 67 with the positive direction of the y-axis this time, measured anti-clockwise. So what that's saying is, if we're looking at the y-axis and we're measuring anti-clockwise, it means we've gone this way. So we're looking at 67 degrees. It doesn't matter where we draw it. I'm going to draw it through the origin just because it sort of makes life less complicated, but it really doesn't matter. We know that's 67 degrees. Okay. So in this case, the angle of inclination is going to be 67 plus 90. So plus that, because that'll give us that whole angle there. So we get 157. And then we know that m is tan theta, tan of 157. And if we work that out, you get a value of negative 0.42. Okay, and now that makes sense. Firstly, that it's negative because it's sloping downwards, and also that it's less than 1 because this line is shallower than a 1-for-1 gradient, which would have an angle here of 45 degrees. So that makes sense. So always checking the reasonableness of your answer. Okay, so there we go. So the relationship between the angle of inclination and the gradient m is just that tan theta equals m. The main thing to remember is that the angle is always measured from the positive direction of the x-axis. So it doesn't matter whether your line is a positive slope or a negative slope coming down this way, you always start here and you measure a little bit like the unit circle, measuring anti-clockwise from the positive direction of the x-axis.